This is video 10.6, surface area of pyramids and cones. Let's start by looking at our vocabulary. A pyramid is a solid formed by polygons. Pyramids have one base and their lateral faces are triangles. So let's start by looking at an example of a pyramid. Here's an example of a pyramid. One base, and its lateral faces are all triangles. You can see here's one here, and one here, and then there are two on the back sides. So we have one base and lateral faces that are triangles. Now a regular pyramid is a pyramid that has a regular base. So for instance, in this situation it's a square. So all the side lengths of this pyramid are the same length, and we call that a regular pyramid. Now you'll also notice that in this pyramid there's this measurement, which is called the slant height of the pyramid. So if you look at this line here, this is considered the slant height of the pyramid, and this will be used in finding the surface area of a pyramid. Slant height is represented by the letter L in the formulas for surface area and volume of pyramids and cones. So this measurement is what we would call the slant height, and it is perpendicular, which this right angle symbol shows, to the side length or the base length of one of the faces. So this would be what we would call the slant height of our pyramid. Now if you notice our pyramid up here, there is also this measurement right here. This would be considered from the measurement from the apex of our pyramid to the base, and again it's at a right angle to the base. That would be considered the height of our pyramid. So this inner measurement from the apex to the base would be our height. The measurement from the point or the vertex of one of our faces at a perpendicular or right angle to the base of the face would be considered the slant height. Now let's identify what a cone is. A cone is a solid three-dimensional figure with one circular base and a vertex. So let's look at a cone here. Here's an example of a cone. It has a circular base. This would be the height of our cone, which is at a right angle to the base. Here's another example of a cone, and again here the distance from the vertex to the base would be considered the slant height, and is shown by using the letter L. This would be the radius of the base of our cone. So this would be an example of a cone. The height is the distance from the base to the tip of the cone, and the slant height is the distance along the edge of the cone from the tip to the base. Now let's start by identifying or finding slant height of cones or pyramids. So in this situation, you'll notice that I know the height of my cone and I know the radius of my base. And I need to find the slant height, and I'm going to round it to the nearest tenth. Right? So to find this distance, you'll notice that my height of my cone and my radius form a right angle. the slant of my cone is like the hypotenuse of a right triangle. So if I consider my height and my radius as legs of that right triangle, I can find my slant height. So I'm going to use the formula a squared plus b squared equals c squared to find the slant height of this cone. So one of my legs is 4.1 squared plus my other leg is 3.6 squared, and that should give me c squared. Don't forget to square your c. 4.1 squared is 16.81 plus 3.6 squared is 12.96, or 12 and 96 hundredths, which equals c squared. If I add these two together, I get 29 and 77 hundredths, which is equal to c squared. Now I really need to know what c is, not c squared. So I'm going to unsquare it, or use the inverse operation, which would be finding the square root of c squared. This will give me c. And I'm going to get an approximation, because I'm rounding it to the nearest tenth. So my approximation of c, or that slant height, would be 5.5 feet. So I'm rounding it to the nearest tenth. So this measurement here would be 5.5 feet. Now let's try the same process with our pyramid. Again, I know the height of my pyramid from the tip of my pyramid to the base, and I know the distance from the center of my base to the edge of my base. I'm looking for this distance here, which is c, or the hypotenuse of a right triangle. So I have a leg here and a leg here. So I'm going to take a squared plus b squared equals c squared, and I'm going to find the slant height of my pyramid. So 8.6 squared plus 5.7 squared should give me c squared. 8.6 squared is 73 and 96 hundredths plus 5 and 7/10 squared is 32 and 49 hundredths, which gives me c squared. If I add these two together, I get 106 and 45 hundredths equals c squared. Again, I'm going to need to use the inverse operation of squaring, which is square rooting. So I'm going to unsquare this. I'm going to get an approximation for c again, which I'm going to round to the nearest tenth. And the approximation of the square root of 106 and 45 hundredths would be 10 and 3/10 meters. So that would be an approximate length or slant height for this pyramid. Now let's talk about finding surface area. Right. For this particular pyramid, I'm going to draw what we called a net. I'm going to start with my base, which happens to be a square. It's a regular pyramid. So it's 28 by 28. So I know the dimensions of my base are 28 by 28 centimeters. And then each of my faces is formed by triangles. And you'll notice that each of the triangles has a right angle showing the slant height of my pyramid. So this would be an example of a net of this particular pyramid. And I know that this slant height is 26 centimeters. And I know that the base of each of these triangles is 28. And this would be my net. Okay. Now my triangles all have the same area because it's a regular pyramid. And I want to find what the surface area of this pyramid is. And so we want to kind of come up with what would be a formula for this particular shape. So I have only one base, so we're going to call that B, capital B, for the area. And then I have these 4 triangles, so it's going to be 4. They're all the same area. And to find the area of a triangle, I need to take the base of the triangle, I'm going to use a lowercase b because I'm talking about a face, times what we called the slant height, or the height of our triangle, divided by 2. Because the formula for a triangle is base times height times a half, or divided by 2. So that would be this portion of my formula. Now let's look at this particular part of my formula, 4b. Right? We have 4 bases here. We have one here, one here, one here, and one here, which also happens to be the perimeter of my base. So I could rewrite 4b as perimeter. So the formula I end up with is the base of my pyramid plus the perimeter of that base times my slant height divided by 2. And this is actually the formula for the surface area of a pyramid. Now let's use that to find the surface area of this particular pyramid. Okay, so we're going to start with the base. The base is 28 by 28, so I'm going to take 28 times 28, and that's going to be my base. And I'm going to add to that my faces. We said that our faces were the perimeter times the slant height divided by 2. So the perimeter would be 4 times 28, because each side of my base is 28, times my slant height, which is 26, divided by 2. I multiply this out, I get 784 plus, and if I take 28 times 4 times 26 and divide it by 2, I get 1,456. If I add these two together, I get 2,240 centimeters. Because I'm talking about area of a 2D shape, it would be centimeters squared. And that would be how I would find the surface area of my pyramid, using this formula. Now let's use the same process to identify how we would find the formula for the surface area of a cone. I'm going to start by drawing a net of my cone. So my base is circular. We know that it has a radius of 13 millimeters. So this represents the radius of my base. And then there is this portion here of my cone, which is the lateral surface area of my cone. And it's formed by the circumference of my base and then its slant height. So it's going to look something like this. This represented by circumference of my base, and then this portion here. So this would be, this measurement from here to here would be my slant height, which we know is, in this situation, 25 millimeters. Okay, now how would we figure out what we would use to try to find the surface area of this shape? Well, the circle's easy because that's just radius squared pi. So it's easy to find our base. But we want to find this lateral surface area part. So let's say that we divide this up into equal triangular pieces and we stretch it out. So this line here will represent the circumference, and then I would have these triangular pieces that I cut out. Now I have this nice straight shape, and let's say I make a copy of this and I place it on top so that I end up with an exact copy of what I have here. So two of them form a parallelogram. The height of my parallelogram is my slant height, or L, and the length of my parallelogram is the circumference. So if I wanted to find the area of this particular part, I would take the circumference, which is represented by 2 radiuses times pi, and I would multiply it times what we call the slant height. Now, the problem here is I don't really want this second copy. I only want half of it. So I'm going to take all of this and I'm going to divide it by 2. What you notice here is I'm multiplying and dividing by 2, which are inverse operations, so I can get rid of this. So we end up with a formula that looks like this. My base times what's left here, which is, or plus, my base plus my radius times pi times my slant height. And this is actually the formula for the surface area of a cone. And that's the formula we're going to use to find the surface area of this cone. So let's start with the base. Alright? That would be 13 squared pi, because it's radius squared pi is how you find the area of a circle. Plus, then I'm going to take this portion that we just created here. My radius was 13 times pi times this slant height, which was 25. Now if I multiply all this out, I get 169 pi, because 13 squared is 169, plus 13 times 25 is 325 pi. Now these happen to be like terms because they're both in terms of pi, so I can add them together, and I get 94 pi millimeters squared, and I have now found the surface area of this cone. Now let's use these two formulas to find the surface area of an irregular solid. Okay, and if you notice, this solid has a cone. So I have a cone here, but its base is covered. So I have a cone without a base. So for this particular shape, the only thing I'm interested in is this part. So I'm going to use this part of my formula that we created. So to find the cone, I'm going to take the radius times pi times the slant height, because I don't need that plus b part. I don't need the base. Then on the bottom part of my shape, let's use a different color here to show this. I have a cylinder. And my cylinder has only one base. So instead of using the formula 2b, I'm just going to use 1b. So for my cone, I'm going to use this formula, but for my cylinder, I'm going to use one base plus the circumference of my base times height, which is the formula you learned for cylinders. And I'm going to solve each of these separately and add them together. Now, the cool thing is my cone fits exactly on the top of my cylinder. So that tells me that my cone has the same diameter as my cylinder, which means they both have a radius of 8 millimeters. That would be half of my diameter. They have the same diameter. So let's start with our cone. It has a radius of 8 times pi times the slant height, which we see here is 11. So this would be the surface area, the lateral surface area of my cone. So if I multiply this out, I get 88 pi. So that is the surface area of my cone. Now let's find the surface area of this partial cylinder. We're going to take base plus circumference times height. Right? My base is radius squared, which is 8 squared pi, plus my circumference is diameter, or 16 pi, times the height of my cylinder, which is right here, which is 7. Okay, if we multiply that out, 8 squared is 64 pi, plus 16 times 7 is 112 pi. I'm going to add these two together, and I end up with 176 pi. And this would be the surface area of my cylinder. So now I know the surface area of my cone and the surface area of my cylinder, and I can add the two together. What's cool is they're both in terms of pi, so they're like terms. I can add them together, and I end up with 264 pi millimeters squared, because it's area of a 2D shape, or a net. Now, there's a problem here for you to try, and this is the end of the video. 10.6 on surface area of pyramids and cones.